Hello my dear students, how are you all? Welcome to Diksha Karnataka YouTube channel. I hope all of you are doing good. Today is day 57 of our series 60 out of 16 KCET mathematics in 100 days. I hope are you having the same energy that I am maintaining for all the sessions, right? Today we're going to discuss another chapter, linear programming from your PU2 portions. We are about to complete PU2 portions. We have one more chapter left after today's session, which will be probability, which will take some time, but today's session will complete the entire chapter. So I'll not give you too much time in this chapter. What I'm going to do is I've taken total of 11 questions that I'll solve today in the class and we'll complete the chapter. Okay, so I'll tell you what is the most important parts from here. If you want me to do something extra in linear programming, let me know, but I don't feel that is the there's a reason for that, there's a need for that. But if there's a need from your side, of course I will try to come up with the solution for your requirements. But as of now, I'm gonna tell you the one and only session for this chapter will be today's session. So please make sure that you are focused, you're solving all the questions with me. Okay, the questions, if it is getting lengthier, pause the video, solve it from your side. If not in the graph paper, solve it roughly and then come back and check your solutions with me. Okay, so I hope you're clear. I'm going to take 11 questions and I'll not teach you any conceptual part, any definition, because that would have gone boring. Okay, so I'll just give you a brief introduction of the chapter and then I'll start solving the questions with you, and from there only we'll understand the entire concept which is there in your chapter linear programming. I hope that is okay. I hope that is clear. So with that, let me start with the session. So first coming up for you is what is, sir, it is going to be the introduction to the chapter. So why we need linear programming, where it is required. So what we do know, we will have an objective. Okay, like that can be in any program or anything that we are doing, we'll have an objective, right? For anything that you start, any plan you start, you'll have objective. Okay, that can be a business idea or anything it is there, you'll have a business objective. That is called as, in our case, objective of the function or objective function. All right, objective function be represented by a letter capital Z. Have a look. And standard form for this objective function is simply ax plus by. Can be given in different form also, but usually we use the standard form only. Okay, so we try to what is our goal? Our goal is to do optimization, sir. Optimization, sir. How do we optimize and what do we optimize? First of all, how do we optimize? By maximizing or minimizing. Sir, how is it optimal value, sir? Think about it. If let's say if my objective function is profit, what do you want to do? Won't you want to maximize your profit? So maximizing, the optimization has what? Has a nature of maximizing. Okay, whereas let's say my objective function is what? Is the revenue, or sorry, is expenses. Then what I'm going to do, I will try to reduce the expenses so that, or a production cost, whatever it is, my goal will be to reduce the production cost to get the optimization in that fashion. So that will be a function where we have to use what? Minimization, and we have to use what? Maximization. So that is the, so first thing to know is objective function. You have to define it very well. Okay, the variable that we use for objective function is Z. Second thing is what is we going to do with this objective function? We're going to optimize it. Which are the ways to optimize it? Either maximizing or minimizing. So what we do? Optimization of Z. I can write this, no? What is Z? Objective function. All right, so how we do it? What is the tool to do it? So we use graphical approach. So we use graphical approach to solve it with the help of what? With the help of linear inequations. Linear inequations means we'll be dealing with a lot of inequalities. You've learnt it in your PU1 portions, but we'll see that when you're going to revise that part as well. So we're going to deal with linear inequalities, okay, and we'll use that graphical approach in the linear inequality to get the optimization for our objective function. So this is clear. Okay, so we will be dealing with the tool that we are using is, what's the tool that we are using is graphical approach to optimize objective function. Okay, now there's some particular things about it. Okay, there's something, few points that you should know. Something called as feasible region. Feasible region means when you draw on the graph, we'll see that. I'll talk about this in detail, when we solve our first question. But try to understand this is the reason where which is going to be most suitable for your solutions, means for your optimization problem. Okay, so this is, we're going to discuss this in detail, don't worry about it. Very simple, not difficult at all. And one more thing is there, something called as corner point. Corner point. Okay, we'll talk about this also in detail when I solve the first question. So corner point is what? Is the point of intersection of the boundaries, okay, for this feasible reason. Means whatever is the boundary or the corner points of this feasible reason, okay, the boundary points. So for example, let's say my feasible reason looks like this. Okay, so I have how many corner points? Please check. So point number 1, point number 2, point number 3, and point number 4. Okay, if this is my feasible reason, one second. I'm not able to draw it over here because of the black background, but I'll show you in the your questions. If I can show you with this. So this is my feasible reason. So if you see the corners, the boundary points you can see on the each of the corner, okay, that will be my corner points. And what we do is, whenever we have boundary reason, to look for the maxima or minima, we use this corner points only. We'll see in the first question itself. Okay, so I hope this is clear what we're doing here. I hope this is clear, right? So few things to remember: objective function, optimization of the objective function. The tool is graphical approach. How do we optimize it? By maximizing and minimizing. They will specify in the question what you have to do. Okay, chali. And few definitions to remember: feasible reason and corner points, and that will be all actually. We will see that in the question. So now coming up for you, as you already know, we have launched a very exciting series for you, the test series. Why did we launch it, sir? Because we thought that there is a need, there is a gap in your preparation. For all of my PU2 students, I felt there is a gap in your preparation. You are preparing, very good. Everything is going good. But how would you be sure that you are, you're up there? You are ready to get that 95% marks. Okay, ready to get that 100% marks in mathematics or in chemistry, in physics. How do we know that? So for that, we have come up with this unique test series, which is called as Success Blueprint Test Series. Okay, so this will be starting from when? 15th of December. Okay, again in more than I think 10 days of time. Okay, chaliye, please check to 12th mock test covering. So we'll talk about structure later. Right now, as I said, why do we need it? The reason is the gap which you had in the preparation will be covered by this. Okay, for a very small cost, we'll talk about that also. We are able to cover up and ensure that you are getting that good marks that you deserve in your PU2 examination. Why it is important, sir, to get that good marks? Why we need only 95%? Why we need very good marks? Two reasons. It will reflect in your career whenever you go in academics. You have to show that you got this much marks in your PU2. Second thing, for your KCET examination, you will need this good marks in PU2, right? So that is very important. Now the structure, if you talk about, there is a total of 12 mock tests. In that 12 mock tests, you'll have 4 part tests. So what's the meaning of part test? The meaning of part test is, it'll be like PCM. So in one test, you'll have physics, chemistry, maths together. So you'll have such 4 tests. So one test PCM, second test PCM, third test PCM, fourth test PCM, and next you'll have what? You will have 8 full length test, subject wise 8 full length test. You'll have 2 for your chemistry, let's say maths for 2, like that you'll have. So schedule will be there for you. So next, if you would like to, this is for PCM. Okay, computer science and biology optional will be over here, covered over here only. What about the next one, sir? The next one will be add-on. If you want, if you are, let's say, having Kannada also as your one of the subject, then you can take this add-on feature also. We are giving from our side, and this will be again available at a very minimal cost. You'll see that later. So please check. Now the benefits of this, why we are using this, how this is unique. First of all, we'll talk about that. Let's see some general features of this test series. First thing is designed by expert faculties based on your latest, your basic new exam pattern. Okay, we are following that to core. Next, what? Video solutions will be given by detailed by faculties. Next, what? Moving on, one shot revision videos will be there. Okay, this will be available before examination. One shot revision video will be available before examination. Now this doubt clarification classes will be there for you for the mocks that you are giving. Okay, this is very important. So that's why these are some unique features of our Success Blueprint test series. So I hope you avail it at this cost. If you check here, the cost is kept at 1,200 rupees, but for December, for this for this month, you can avail it at 599. 599 you can avail only for this physics, chemistry, maths with biology and CS optional. Okay, only for this part. If you want to have by let's say Kannada also. As I said, it's an add-on, okay, at a minimal cost of 199. When you put them together, if let's say if you're somebody who has taken Kannada also as your subject, then you have to add them together. It's gonna come as 798. So pay this amount, you'll get this thing added. How to do that? There's a detailed video available. I hope you watched this launch session. Go ahead. Link will be given in this to purchase this thing, the test series. The link is given in the description, so make sure that you go and visit the link. You'll get the features, you'll get to know. It's very step-by-step process, not a difficult thing to do. Enroll yourself, get it done. If you have any queries, let us know in the comment section that how to get this, purchase this series. A lot of people have already purchased, so I thought more numbers will come, but very satisfying numbers of students have taken this seriously, and they've taken this this test series. I'm very happy for them. I congratulate them that you have done that. Good bacha, you took a decision, okay, for your benefit. So now let's look at the question number 1. Determine the maximum value. So optimization is what? Of maximum kind. The function is given. What's the function, sir? Your objective function is given like this. Have a look. 11x plus 7y. Subject of the constraint is 2x plus y less than 6, less than equal to 6, x less than equal to 2, and x greater than equals 0, y greater than equals 0. What's the meaning of this, bacha? This is called your, this shows what? Your first quadrant, right? X greater than 0 means more above the, on the right of y axis. Correct. And y greater than 0 means on above the x-axis. Chaliye, okay, let's plot the graph first. As we said, we talked about this, that we're going to use the graphical approach to solve our questions. Okay, I'm not using a scale, so please check. My lines might be a little bit not straight, so forgive me for that. So last 2 means first quadrant. So I've taken the first quadrant. Chaliye, now I have to plot what? I'll plot all the curves, bacha. So first curve is what? Put aside the objective function first. Z equals to 11x. 1 second. Objective function, sir. How much is that? 11x plus 7y. Okay, 11x plus 7y. Now we'll plot the linear equations first. Then we'll see the inequality part. First equation is what? 2x plus y equals to 6. When I take y is 0, what is x value? 3, right? When y is 0, x is 3. Okay, so please check. Y is 0, x is 3. Somewhere over here, x 3, 0, right? 3, 0. I hope that is visible to you. Let me write it again. If not, so 3, 0 is my first quadrant. Okay, first coordinate. 3, 0. When x is 0, y is 6. X is 0, y is 6. Somewhere over here. X is 0, y is 6, bacha. Clear now? 0, 6 also is there. So if I draw the line through them, I can draw like this. Please check. Yes, sir. What's the line's equation? Please check. We are looking for less than sign, right? So line's equation is what? First line's equation is going to be like this. I can write here 2x plus y equals to 6. We're looking for less than symbol. Please have a look. Here, sir, less than. So I can write what? I'll have the arrow pointed like this, sir. Like this, sir. Clear, right? Clear, no? Okay, great. So first one is plotted. Now x greater than 2. Where's this line x greater than 2? Have a look. Isn't this the line somewhere here? This is x equals to 2 line. Okay, less than 2, right? Means on this side again. Please check on this side again. So what is my feasible reason? What is my feasible reason, sir? Have a look. My feasible reason is over here, bacha. Have a look. Can you see that? This is a feasible reason, right? So what are my coordinate points? If you say I have to check, my coordinate points is 0, 0. 1 second, 1 second. I have taken highlighter only. Let me move to pen. Okay. So my common coordinate points are 0, 0. The origin. Over here I have 0, 6 over here. What's the coordinate point, sir? 2, 0, sir. 2, 0. Correct? Correct. Now, please check. Please check. I'll show you. Don't worry about it. This point, bacha. I'm talking about this point. Please check. X is what? 2 here. Y means it's on x-axis. So, the coordinate is 2, 0. Clear? Hai? Okay. Now, we have another point over here. This also will choose what is the value. This is also a coordinate point. We'll check the value of x and y. So on this line, x equals to 2. Okay. This one, bacha. x equals to 2. What I have? Everywhere x is 2. Okay, so in this equation put x as 2. I'm gonna get 2 times of 2, which is 4, plus 2 will be 6, right? So what is this point coordinate? Sir, 2, 2, sir. 2, 2, sir. Great. So the coordinate points that I have right now, I can list it over here. Corner points. Please check first one. Origin, sir, 0, 0. Next one, sir, 0, 6. Next one, sir, 3, 0, and one, not 3, 0. Excuse me, that's not part of the graph. 2, 0, sir. 3, 0 is outside the shaded region, right? This is the feasible region over here. So next one is what? 2, 2. Where is the feasible region? Let me just mark it for you. This here, you can see this part here is your feasible region, sir. Feasible region, right? The green part that I've shaded, that's feasible region, and the coordinate of that is what? Your coordinate points. Let's check for the z max value now. Let's check for z max value. Means basically I'm going to check for the objective function's highest value. So if I check for z max at 0, 0 is simply 0, sir, or if not z max, simply write it as z value. Okay, we'll see where is it z max. 0, 6. So 11, if I put 11 into 0 and 7, 6 is 42. 2, 0. So 22 plus 0, so 22. 2, 2. 22 plus 14. 36. So what is my z max value? You can check from here. This is my z max value, which occurs at which coordinate? Which occurs at 0, 6. Means my maximum value for the objective function z equals to 11x plus 7y is 42, and it occurs at the coordinate 0, 6. 0, 6. Please have a look. I hope this is all visible to you. Yes. Okay. Let's move on to question number 2. Okay. Maximize another function z equals to 3x plus 4y subject to the constraint x plus 4 less than equal to 4. What is the first step to do, sir? Let's draw on the graph. Let's check it out, sir. This thing, x axis, y axis. Let's draw the equation first. So before writing the equation, we'll write this objective function. Okay, now equation, we'll not write the inequality, we'll write the equation, sir. So we'll write what? X plus y. Instead of writing less than equal to, we'll write what? Equal to 4. It's a equation in 2 variable, something like this. Please have a look. This is the graph. Okay, when x is, origin is this 0, 0. When x is 0, y is what, bacha? Y is 4. And when y is 0, x is again 4, sir. Right now, this is the curve. Then the last 2 represents what, bacha? Have a look. This 2 represents what? Again the first coordinate. Okay, first quadrant. Please check. So my condition is what? The condition is less than equal to 4, means somewhere over here. Okay, so what is my feasible region? I know you can give me answer now. Feasible region will be this stated region will be my most feasible region. Correct. Let's look for the corners. Do we have all the corners, sir? That's what we do. We have to check for the corners. Do we have all the corners, sir? Yes, we do. 0, 0, 4, 0, and 0, 4. Are there any more corners? Of course not, sir. It's a triangle. It'll have only 3 corners. Okay, sir. Great. Let me write then again here corner points. Corner points. Okay. And next is what? My z value. What's the corner point, sir? 0, 0, 0, 4. And 4, 0. Write the z value for 0, 0. Put here 0 and 0. I get 0. X as 0, y as 0. In the objective function, if I put, both are coming 0. Put x as 0, y as 4. What I'm getting? 0 plus 16, right? So 16 is coming. X is 0 over here. Y is 4. So 16. Now put 4, 0 again. So 12 and then 0. So you can clearly see this. This is my required condition. Answer. This is the z max value, and we're looking for maxima only, so z max value occurring at the point 0, 4. Is the question simple or not? Very simple problem. Very, very simple problem. Have a look. Question number 2. Okay, we were looking for the maxima. For that we found what? Our feasible region. This is our feasible region. Have a look. and the coordinates of the feasible region is given like this: 0, 0, 0, 4 and 4, 0. Clear hai? Okay, why the direction like this? Why this direction, sir? Why only this direction, sir? Please check. Why like this, sir? Because the equation is what? X plus y less than 4. For that reason, bacha. Okay, please have a look. Is this clear? Let's move on to question number 3. I hope this was clear, okay, and it's visible also. Question number 3, sir. Coordinate points of a feasible region of inequality gives us optimal solution. Whatever it is, whether it is maximum, minimum, we'll see that. Now we have to verify that. But actually, it is going to be what? Optimal solution only. Not the constraints, not objective function. We are looking for what? The optimal solution of the LPP, the linear programming, or what we're gonna get? Basically, the optimal solution for our objective function only. Whether maximum or minimum, we don't know. We have to optimize it. We have to see the condition to know it. So answer is what? Option number A. Now moving to question number 4. In solving the linear programming problem, minimizing f. Okay, this is the, what is this, sir? Here there is no z given, sir, but this is my objective function. If you want, I can write it as f or z equals to 6x plus 10y, sir. This is my, what is it? My objective function. Okay, I have to do what? What's my optimization? Minimize. In this case, you have to minimize. Great. Constraints are given: x greater than 6, y greater than 2, 2x plus y greater than equal to 10. चलिए प्लॉट करते हैं. Let's plot the curve. But this is not the end of it. They are asking find the redundant constant, means the constant without which we can still get the same answer. This is my origin, bacha. X-axis, y-axis. We need only first quadrant, reason being greater than 0 and y greater than 0. Okay. X greater than 6. So we'll write this part first. X equal to 6 we'll write, and there's another equation. Y equal to 2 we'll write. How will this graph look like? X equal to 6 will something be like this, sir. है ना? This is this curve. X equals to 6. Y equal to 2, sir. Somewhere over here. Please check. Y equals to 2. We're looking for X more than 6, right? More than 6 means on this side, na? And Y more than 2. It means again up from here. Okay, so my required reason right now we have one more curve to solve. What is that? 2x plus y equals to 10, right? Take here, if I take x as 0, y is 10, no? If I take x as 0, y is 10, sir. X 0, y is 10. Somewhere over here. X is 0, y is 10. When y is 0, x is 5. Y 0, x is 5. Somewhere over here, please check. X equals to 6 is over here, means over here somewhere. 5, 0. How will the line look like? Please check. Like this, sir. Okay, like this, sir. Great. Again, what is the inequality? Greater than equal to. So I can write what? I can write like this. Above all of this. Okay. Now you can see here, even if I don't have this curve, my condition still stays. First of all, what is my feasible reason? Please check. My feasible reason is what, bacha? Have a look. My feasible reason is over here. Won't you agree? This whole thing is a feasible reason. Going on both sides, till infinity. Yes, going on both sides till infinity, sir. Correct? Because above y equal to 2, somewhere I can go till infinity. On the right of x equal to 6, I can go again till infinity. Okay, means this point is unbounded reason. So this is my feasible reason. This is my what? Feasible reason. 1 second. This is my feasible reason. I don't think you can see it, right? I don't think you can see it. So let me just, I cannot erase it. If I erase it, I'll end up erasing everything. So I'll just leave it like that, okay? I'll write with a different color. So this is my feasible region, bacha. Now tell me, does this line affect this region? No sir, because using these two lines only, these two constraints, x greater than 6 and y greater than 2, I'm getting the feasible reason. So this is the line which does not, this constraint I don't require only. It means my reductant constraint is what, bacha? It is going to be this 2x plus y, okay, and what is that? Greater than equal to 10, okay, and what? X greater than equal to 0, and what? Y greater than equal to 0. I don't need that. This, once I say y greater than 2, if I say y greater than 2, it means already greater than 0, right? If I say x greater than 6, it means it's already greater than 0, right? So I don't need these two also. These two also I don't need. Even this I also don't need. You can see in the graph. I don't need this part, because this any answer, any point you consider over here, any point you consider in this feasible reason will automatically satisfy equations over here. Correct? Agreed? Okay. Let's have a look once more before I move on to question number 5. Chaliye, moving on. Question number 5, sir. Question number 5, sir. Maximum value of z 7x plus 11y subject to 3x plus 5y less than 26 and 5x plus 3y less than 30, okay, occurs at. Chaliye, before going to do that, before going to plot this on the curve, I hope I've taken a curve. Yeah, I've taken a curve. But before I go and do that, let me just solve the inequations into equation form first. So what I'm having first, I'm having this as my objective function, 7x plus 11y. Objective function is there. We have to do what? Maximize. So what is my optimization? My optimization is what? To maximize value of z. Cool. Okay. Subject to 3x plus 5y less than 26. Inequations are given. I have to write in the form of equations first. 3x plus 5y equals to 26. Great. Next is what, bacha? Next is another one is there. I have what? 5x plus 3y equals to 30. Now please check. If I take for this one, if I take over here, x is 0. X is 0. What is y value? 26 by 5, sir. What is the y value, bacha? 26 by 5 means 5.2. Please check. 26 by 5. 25 by 5 is 5, right? I have 1 left. 1 by 2 is what? 0.2. So 1 by 5 is 0.2. So 25. So 26 by, if I put this x as 0, I get y as 26 by 5 becomes 5.2. Now if I take y as 0, what's the x value? 26 by 3, right? So 2 8s are, so 3 8 are 24. So I'm getting what? X equals to 8, 3 are 24 plus 2. Correct? 8 is 24 plus 2 is 26. Okay. So something like 8.666. It's not a, it's a recurring number. So 8.666. Okay. Chaliye, I'll write it like this. 8, 2 by 3. Great. So my values are known now for this. What about this curve? This is easy to find, right? This is very easy. Have a look. When x is 0, y is what? 10. When x is 0, y is 10. When y is 0, x is 6. When y is 0, x is what? 6. Please check. Now I can plot this two curves to the straight lines on the graph. Okay. Have a look. X here, y here. First curve is what? 0 and 5.2. So y axis. 0 and 5.2 somewhere over here. 0 comma 5.2. Great, sir. Next is what? 8, 2 by 3 comma 0 somewhere here. Please check. Over here 8, 2 by 3 comma 0. Okay, great. This is it. Next what? So I have to join this line like this. Which is the equation? Equation is 3x plus 5y equals 26. 3x plus 5y equals to 26. Okay, we are looking for greater than or less than? Less than. So it means what? It means below. Okay, below both of these conditions. Okay, chali. Now next line, let's plot the next line. How much is that? X is 0, y is 10. X is 0, y is 10, somewhere over here. X is 0, y is 10. Okay, great. Other one, what is it? X is 6, y is 0. X is 6 over here, y is 0. So line will go like this. What's the curve name? Please check. The curve's equation will be 5x plus 3y equals 30. 5x plus 3y equals 30, sir. Equals 30, sir. Great. Now we are looking for again what? Less than? Less than. Yes, sir. Less than only we are looking for. It means again below this also. Below this as well. Simple. Okay. So I'm looking for this area. So basically, any other constraints I have? Okay. First quadrant. I also have constraint for the first quadrant, bacha. Great. So I can write this simply as the highlighted region as, check here. This, no? Can you see this? This is my feasible region. This is my feasible region, sir. Yes. And what are my coordinate points? Okay, please check. So my coordinate points are 0, 5.2, 6, 0. This origin I know. This origin I know, 0, 0. Okay. 0, 0. But I'm missing this point. Okay, I'm missing this point. Okay. Isn't that the solution of both the equations? Okay. Isn't that point the solution of both the equations? Correct. Let's solve the both linear equations. If I do that, add them over here. This is my equation 1, equation 2. Add them, bacha. Okay. 5x plus 3x, 8x. 5y plus 3y, 8y. Equals to what? 56. Divide everything by 8. You're going to get what? X plus y equals to 7. Equation number 3. Now subtract them. Subtract 2 minus 1. Please check over here. Equation 2 minus equation 1. 5x minus 3x. So 2x. 3y minus 5y. So minus 2y. 30 minus 26. So again 4. Now cancel everything by 2. You're going to get what? X minus y equals to 2. Equation number 4. Now if you add equation 1 and 2, what are you getting? Please check. If you add equation, sorry, not 1 and 2, 3 and 4. Do that. You're going to get what? 2x equals to 9. 2x equals to 9, sir. So from here I'm getting what? X equals to 9 by 2. From here I'm getting, 1 second, X as 9 by 2. X as 9 by 2. Please have a look. So my X value is coming as 9 by 2. What's my Y value? Put it over here. So 9 by 2 minus Y equals to 2 from this equation. So I want to find the value of Y. So Y will be equal to what? 9 by 2 minus 2 equal to Y. 9 by 2 is how much? 9 by 2 is 4.5. 4.5 minus 2 is what? 2.5 equals to Y. How much is that? Simply 5 by 2. My coordinate is what? 9 by 2 and 5 by 2. X is 9 by 2 and Y is 5 by 2. Let me write it over here. This is 9 by 2 comma 5 by 2. So now I know all my 4 coordinate points. Let me list it down. Corner points, sir. Okay. So what is it? Please check. 0, 0 first one. Next is what? 6, 0. Next is what? 0, 5.2. Okay. The other one is 9 by 2 comma 5 by 2. Right. All of my coordinate points are listed over here. Please have a look. 9 by 2 comma 5 by 2. Clear hai? We're gonna find the Z value now. Please check. Z is what? Z was 7x 11y. Z was 7x plus 11y. If you do that for this, 0, sir. For this 6, 0, 11, 7, 6 is 42. 0 into 11 will be 0 only, right? So 7, 6 are 42. What about this? 7 into 0 will be 0 and 11 into 5.2. How much is that? Please check. 11 into 5.2. So 11 5s are 11 5s are 55 and 11 2s are 22. So 2.2. 57.5. Please check. No, 57.2, not 5. Excuse me. There's a value for this. 11 into 5 is what? 55. 11 into 0.2 is what? 2.2, right? So we're gonna get what? 55 plus 2.2 is 57.5. Please check. What about this? I have to do it 7 times of 9 by 2 plus 5 times of 11 by 2. 63 by 2 plus 55 by 2. I'm getting what, bacha? I'm getting here 5 plus 3 is 8. 6 plus 5 is how much? 11 by 2. How much is that? 250. This is 59, right? Correct, na? 60 by 16 to 2 is what? 120. So 59 to 2 will be 118. Let me check the calculation. 7 into 3 is 63 by 2. 55. 3 plus 5 is 8. 5 plus 6 is 11. Correct. So my maximum value is this. This is my Z max value. And occurs at which coordinate? 9 by 2, 5 by 2. What are they asking? Okay, occurs at. That's what they're asking. Option number A is the correct answer. Option number A is the correct answer. Okay, please check. This is, I've taken the graphical approach. If you want to do it, what you can do, they're given the options. Substitute in the function 7x, 11y, get the answer. Got it? Yeah, there's a way to do it. But if it was not a subjective, objective question, you can solve how? How you can solve? Using the approach that I gave you, graphical approach. Have a look. I hope this is all visible to you. Okay, solution part. The graph is clear, right? If you have any other problem understanding or seeing the graph, let me know in the comment section. Okay, let's move on to question number 6, sir. The maximum value of z subject to x minus y greater than 0 and x plus 3y less than 12, okay, will be how much, sir? Will be how much, sir? Okay, we have to draw the graph, and before that, let's add the objective function. First step is what? Write the objective function, sir. Z equals to 6x plus 8y. Okay, we are not formulating it, they have already given it. Okay, so we've written that. Next is what? Next is my equation. So x minus y, I'll write in the form of equation, so it's equal to 0. Okay, so basically the first one is there. Next is what? X plus 3y equals to 12. Okay, chaliye, let's plot the curve. First one is going to be what, bacha? Y less than x, right? From here I can bring this y on the other side. Y less than x, sir. Okay, great. This is 0. No, that's x, right? 1 second, sir. This is 0, 0. Y equals to x line is like this. You know this. But y is less than x means I want this reason. This is y equal to x line. Chali. Moving on. Plot this x plus 3y equal to 12. When x is 0, y is 4, right? X is 0. 3y equal to 12 means y is 4. X is 0, y is 4 somewhere over here. Please check. 0, 4. And when y is 0, x is 12. When y is 0, x is 12 somewhere here. Join the line. Join these lines. Okay. What we are looking for? We are looking for again less than. Less than means this. So we are looking for below this and over here. Which quadrant? First quadrant. How come, sir? Check here. Okay, great. Now we'll write and draw our feasible reason, which looks like this. Have a look. Okay, have a look. This is my feasible reason, sir. This whole thing is what is called as feasible reason. We're missing corner points, right? We have 12, 0. We have 0, 0, but we have this point missing. We have to find that value. Please check. I have to find this value, right? This is another corner point. We know that on this line, y equal to x, and the line, what line is this? Let me see, write that. X plus 3y equal to 12. X plus 3y equals to 12. This point will be, if I call this point to be point A, will be a solution of both the lines. Correct? It means the equation will be, the value of will satisfy, the value of x and y will satisfy both the equations. Condition check here. X equals to y. X equals to y. Have a look. X equals to y from here. Substitute in this. I get what? Y plus 3y equals to 12, right? So 4y equals to 12. So y equals to 3. Check here. Put y as 3, sir. 3 into 3 is what? 9. So what will be x value? Again 3 only. So what I'm getting? X equals to y, and the coordinates are what? The coordinates of this is 3, 3. 3, 3. Chali. Now we have to look for, so again write what? Same condition is repeated. Corner points and z value. Corner points and z value. What's the corner point here, sir? 0, 0, 3, 3. The last one, 12, 0, 12, 0. Z is what? What's z, sir? 6x plus 8y. Z is 6x plus 8y, put here. So 0, put here. 18 plus 24, right? 6 into 3 is 18 and 8 into 3 is 24. How much is that, sir? 4 plus 8 is 2 and 3 plus 1 plus 1 is 4. 12 into 6, so 72 plus 0. So what is the answer, sir? 72. The maximum value is this. This is my maximum value of the objective function z. I'm looking for this value only. Answer is A. Please check. The maximum value for the objective function z given as 6x plus 8y is coming as 72. Check out the solution once again over here. I hope this is clear. Moving on to question number 7. The maximize z equal to 2x plus 3y, okay, subject to the constraint x plus y greater than 2 and x plus 2y greater than 3. Okay, sir. First equation, let's write. What is that? Z equals to, I have 2x plus 3y, no problem. X plus y greater than 2 means x plus y equal to 2 is the line. Draw this line here, bacha. Draw this line, please check. This is my x axis, y axis, origin. X plus y equal to 2 means this is the line. Please check. 0, 2, 0 and 0, 2. Great. What is this line? X plus y equal to 2. We are looking for what? Greater than symbol. We are looking for greater than means, have a look, means above. Okay, chali. Last one is what? X plus 2y greater than 3. Please check. X plus 2y equal to 3, 5, right? X is 0 means y is 1.5. Please check. This is 2y, right? X is x plus 2y. 1 second, bacha. X plus 2y equal to 3. X is 0 means y 2y equal to 3 means y equal to 1.5. Okay, so over here somewhere. 1 second. 0, 1.5. Okay, when y is 0, x is 3. Somewhere over here. 3, 0. Join the line like this. Okay, this curve's equation is x plus 2y equal to 3. This curve equation is x plus 2y equal to 3. We are looking for what? Again, greater than symbol. We are looking for again what, bacha? Check here. Greater than. So what's the region now? The region is again above all of this. Above this line also. So what is my required shaded region? Have a look. My feasible region will be this, bacha. It will not go behind y-axis because it is in the first quadrant. X, y both greater than 0. It will come back like this, touch this line and again go like this and over here like this and keep moving on to infinity, right? To the infinity like this, both side. Please check. What is this, sir? My feasible region. 1 second. My feasible region, sir. Unbounded was the answer. Unbounded solution C. Maximize, if you do know, you'll have unbounded solution as your answer. Option number C. Simple, very simple question. Clear, right? Question number 8. Question number 8. Okay. This will be homework. Okay, same question. So homework. Solve and comment your answer. Comment. What are you gonna comment, sir? Got it right, sir. Got it right, sir. Okay, great. So if you check your option, I'll give you the answer for this. Answer should be Please check. Yeah. Yes, option should be C only for this also. Please check if I have got it wrong. No, I'll let you know in the comment section. But if you, I think the answer is C only. Cross check once, but solve it before. Don't just say, sir, okay, answer C. You do not say with confidence, sir. Please solve it. Then you let me know if this answer is coming in different. How you gonna solve it? Same graphical approach. Okay, chaliye. Okay, we have to maximize the objective function minus x plus 2y. कर लेंगे? Of course, sir. Moving on to question number 9. Okay, question number 9. X minus y less than equal to 1, x minus y greater than equal to 0 are the constraint for the objective function z equals to x plus y. The maximum value of z has what, sir? Maximum value of z has what, sir? Please check. So let me write z first. X plus y. Write the equations from the inequalities. X minus y equal to 1. Okay, when x is 0, y is minus 1. Okay, when x is 0, y is minus 1. Okay, this is my point, bacha. 0, 0. Have a look. Alright, when x is 0, y is minus 1 means somewhere over here. Will you agree? 0, minus 1? Of course, right? When you take y as 0, x is simply 1. When y is 0, x is simply 1. This is my line. What's the equation? X minus y equal to 1. X minus y equal to 1 is my equation of the curve. We're looking for what? Less than means below, right? Yeah. Okay, means over here. So I'll get what? Over here. Now x equals to 0, other curve. Please check the other curve. I have x minus y equal to 0. It means y equal to x. Y equals to x. If I do this, I'm gonna get the curve to be this one. Okay, this is my y equal to x curve. Y equal to x curve. Okay, great. And what is this? Y less than x, right? Means where, bacha? Over here. Correct, right? This is the reason. Okay, can we come below? We cannot, because it has to be in first quadrant. It has to be in the first quadrant only. Please check. So I have to go above again over this. All right, so what is the shaded region, bacha? Please have a look. Please have a look. Okay, so if I go ahead and do this, the highlight, if I highlight this part, will come like this, right? Is it bounded? Yes, sir. No, sir. It is not bounded, sir. It looks bounded because of the two lines forming that, this box. But on this side, right side, it can go till infinity, na, sir. On this side, it can go till infinity, sir. For that reason, it is unbounded, sir. So option is going to be again, okay, B. Option is going to be B, bacha, unbounded only. Now, if you have a doubt in this question regarding, sir, how did you take for this line x minus y equal to 1 above? Please check. I'm going to get y plus 1, right? So more than 1 has to be there. So more than 1 will come like this. Okay, chali. Means x has to be less than y plus 1. So it will be this line only. Will be above. This is your curve. Please plot it. You're going to get the same answer as option B. If you are getting a different answer, let me know in the comment section. We will cross check. Okay, आगे बढ़े. Question number 10. We are about to complete the session, बच्चा. We are about to complete the chapter. Yes. Okay. The true statement for the graph of any equation 3x plus 2y less than 6. Okay. There is no objective function here. 3x plus 2y less than equal to 6. Arey, this is parallel line, right? Please check. They are parallel lines, no? Are they not? 3 into 2, 2 into 2, 6 and 4. Parallel lines, sir. The factor is what? Into 2. Remember this? If you draw this, if I draw this line on the curve, I get what? When x is 0, y is 3. When x is 0, let me show you. When x is 0, y is 3. Over here. 0, 3. When y is 0, x is 2. When y is 0, x is 2. The other one, this is the line first one. Okay. Second one, when x is 0, y is 5, right? When x is 0, bacha, y is 5. So over here, okay, so this is going to be 0, 5. When y is 0, x is 20 by 4, 6. So how much is that? 10 by 3. 3 point something. How much is that? 20 by 6. I can write here. 20 by 6. Okay. 20 by 6, 0. You don't have to plot the graph also for this one. As you can see directly here, the ratio is what? Always 2. 3 by 6 and 2 by 4 is equal, right? So parallel lines. These two are parallel lines clearly. 1 second. Please check. They are parallel lines. Means what? Both graphs are disjoint. Option A looks right. Please cross check. But option A is right. Both graphs are disjoint. Parallel lines, right? So both graphs are disjoint. Okay. Question number 10 is over. Moving to question number 11, the last question of the day. The minimum value of z equal to 13x. Okay, constraint is given like that. Array. I will give you the solution, but you have to do this as also homework. So I have given total of 2 homeworks today. Homework, comment your answer. Comment your answer. I think the option number B is correct. Plus please cross check. Okay, verify it after solving it, and if you get the same answer right here, got it right, sir. Okay, so this completes bacha your linear programming. If you have more questions, if you want any other thing to do for me to do in this chapter, I don't think there's a need of it, but if you want me to do, I'll do it certainly. Okay, but for now, this completes the chapter. Again, this week's mocks will be on linear programming and your 3D. So we'll see. I don't think we'll be having a lot of PYQs, but we'll club them together, and whatever questions are there, I'll add additionally questions will be from KCET ready problems. So I think 15-20 questions will be from PYQs from both the chapters, and the last few questions will be from your your KCET ready problems. I will include in your mock test. Okay, it'll be easy mock test. I hope you score well. Okay, so with this bacha, I would like to conclude our session, completing our chapter linear programming. Okay, so please take care, please keep working hard. I know times is getting tough for you, you're finding less time to watch the sessions or plan your work. I know you're very serious right now, but if you need my help, let me know in the comment section. Whatever I can do for you, I'll certainly do. And please make sure that if you are a PU2 student, go and purchase the test series. It will be a very, very helpful thing for yourself. You can see on our platform everything is available for free, but why this paid content? Because it will certainly benefit you. Okay, for that reason, make sure that you get this test series, and I'll see you in the next session. Okay, till then, take care. Bye bye.